Hi everyone, today we're going to talk about derivatives of exponential and logarithmic functions. So this is another set of derivative rules that we just have to have memorized so that we can take all the derivatives that we need to. Before we get started, one note I want to make is here you'll see that we're using u for our independent variable. So this is just really the same as calling it the derivative with respect to x of a to the x. We just happen to be using the variable u. So I don't want anyone to get too thrown off by that. So our derivative here, now when we're talking about a to the u, we're talking about a being a constant. So I'm going to make a note that a is a constant. So it could be a function like 2 to the x. That's the type of function we're talking about here. So my derivative with respect to u of a to the u is going to be a to the u times the natural log of a. Okay. Over here we have our logarithmic function. So the derivative with respect to u of log base a of u is going to be 1 over u times the natural log of a. For our derivative d du of e to the u, the nice thing here is this one, e to the u, is its own derivative. The derivative is also going to be e to the u. And then last but not least, the derivative of natural log of u is going to be 1 over u. So again, those are 4 rules that you're just going to have memorized. So let's go ahead and look at some examples. So for number 1 through 4 here, we're finding the derivatives of the following functions. So for my first one, f of x is e to the x. This one's nice and easy. My derivative f prime of x is also just e to the x. For number 2, f prime of x, this function here, 3 to the x, is my a to the u here. So the derivative is just going to be 3 to the x, that's my a to the u, times the natural log of 3. Okay, for f of x equals the natural log of x, we'd say f prime of x is just, this is our rule here, is just going to be 1 over x. And then last but not least, this was our second rule here. So f prime of x equals 1 over x times the natural log of that base, which in this case was 4. So those are some nice basic examples without chain rule. So now let's look what happens when we insert some chain rule into this. So for number 5, here's what I have to notice. If this were just e to the x like it was here, then we wouldn't need chain rule. But now we have this 2x, which is going to require us to use chain rule. So chain rule says to find the derivative, we're going to take the derivative of the outside function, which was e. I know that the derivative here of e to the u is just e to the u. So my derivative is going to be e. And the 2x is going to stay the same. Now I have to go and take the derivative of my highlighted part here, which is just 2, so I multiply by my result by 2. And a lot of times just by convention you'll see I'll put the constant out front. So 2e to the 2x. Alright, number 6, again, we have a chain rule here because in my exponent isn't just x, it's 2x plus 1. So the first thing I need to do is differentiate what would have been 4 to the x. So I'm going to have g prime of x is 4 to the same exponent, 2x plus 1. And then I need times the natural log of 4. That's the derivative of my outside function. Now I need to differentiate the part that I highlighted in yellow. The derivative of 2x plus 1 is just going to be 2. Now here we have to be careful. I can't multiply the 4 and the 2 because 4 is the base of this exponent. So I'm just going to leave my answer just as it is. Alright, for number 7, here we have our natural log. So I know my rule says the derivative of the natural log is 1 over everything that was in parentheses. And then again, I have to multiply by the derivative of what was in parentheses, which is just 4. So I can write this as 4 over 4x plus 5, and that's really all we can do with that answer. All right, last but not least here is now we have our logarithmic function. Inside I have a 2x minus 1, which I know is going to cause me to have to use the chain rule. So my derivative, p prime of x, is going to be 1 over 2x minus 1 times the natural log of the base of my exponent. Well, when we have log with no base here, that means it's base 10. And then I'm going to multiply by the derivative of what was highlighted here, which is just 2. So I get 2 over 2x minus 1 times the natural log of 10. And that would be our derivative with the chain rule. All right, let's go ahead and flip the page. All right, now we just have, again, some more chain rule, it looks like, or more complex functions. So let's go ahead and take a look. So for this one, I have y equals e to the x plus x squared. So again, obviously this is going to trigger chain rule for me. So I'm going to go ahead, sorry about that, and name my derivative. I'm going to call this y prime. So my derivative is just going to be e to the x plus x squared times the derivative of what I've highlighted here in my chain, which is going to be 1 plus 2x. And that would be our answer. For number 10, I'm going to use dy dx here. Again, either of these two notations is fine. I just want to use them all so we get used to seeing both. Now, my derivative here, excuse me, I actually did this wrong. I have to be more careful with my notation. So let me start again. It's the derivative of y, but in this case my variable is t, so I'm actually doing dy dt. So we need to be careful that we're using the appropriate variables. So now, my derivative for just 2 to the t is going to be 2 to the t times the natural log of 2. The derivative of minus 3 is just 0, so this would be my complete derivative. All right, now in number 11, we actually have quite a bit going on here. I can see I have my logarithmic function on the outside. Then I have my exponential function here, and my actual exponent is a function of x. It's sine x. So I've got quite a few layers going on here. So let's take a look. The first thing I'm going to do is take my log base 2. I'm going to take that derivative. So I'm going to have 1 over my 3 to the sine x times the natural log of 2. There's the first part where I'm just differentiating the log. Now that's been taken care of, and I need to differentiate 3 to the sine x. So that's going to be 3 to the sine x times the natural log of 3. And the last part I have to do is go all the way inside and differentiate my sine. So I'm going to multiply by cosine of x. So let's see what happens here. I've got on top 3 to the sine of x times natural log of 3 times cosine x all over 3 to the sine x times ln 2. So in this case, since this is all of these factors are being multiplied, same thing on the bottom, I can actually cancel my 3 to the sine x. So I'm going to get natural log of 3 times the cosine of x all over the natural log of 2. So that one was a pretty complex one because we had kind of two chains in that problem. All right, the last part of this is what we actually talked about yesterday when we were working with our trig function, and it's being able to interpret a limit as a definition of the derivative. Okay, so the goal here is to be able to recognize when an expression represents the limit definition of the derivative, and then we can use our derivative rules to determine the actual value. So a couple things we need to be able to recognize, right? Recognizing that limit definition is going to make calculating the limits easier. So we had two ways of writing this. We said that f prime of x was equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. That was kind of method 1. Method 2, we said that f prime of a was equal to the limit as x approaches a of f of x minus f of a all over x minus a. So as an example, we could be asked to figure out the value of this limit. Now, before we knew our limit definition here, we would have had trouble because we know that if we plug 2 in, we would get 0 in the denominator, but we don't have algebraic methods to be able to fix that. But here's what we have to recognize. This limit is actually this form of the limit definition. So in other words, my f of x here is natural log of x. So my function is natural log of x. My a value here is just 2. So what we need to recognize is this limit definition is actually just asking for f prime of a. Or in our case, then, we're trying to find f prime of 2. So now I know what they're asking for. I know they want f prime of 2. So my function, which was f of x equals natural log of x, I know then that f prime of x equals 1 over x. So then I can calculate f prime of 2 is just 1 over 2. So if I can recognize that this is just the limit definition of a derivative, then I can use the rules that I know to find the actual derivative. So now let's look at number 12, and this will be the last problem for this video. So here, clearly I'm using this form of the limit definition, x plus h minus f of x all over h, and I know that's equal to f prime of x. Now in this case, if I look, I can see my function f of x. I see here that it's my e to the x. Now I am evaluating, I can see this value of x is actually going to be 3. So what this problem is really asking me is to find f prime of 3. So now, again, I can use derivative rules to find that. I know that f of x is e to the x. F prime of x is also e to the x. So to find f prime of 3, I'm going to plug 3 in for x, and I get e to the 3rd power. Alright, so that's it for the video notes. The next thing you'll do then is work through the practice on the next 2 pages to make sure you've got these rules down. Again, these are going to be rules you have to memorize, so you might want to think about making flashcards or some other way of giving yourself enough drill on these that they become automatic. Alright, good luck with the practice.